our second type of equation in this section is what's called a rational equation. A rational equation is an equation in which the denominator contains a variable. These equations look really similar to the ones we saw in example 2, and they'll follow a similar solving strategy where we'll use the common denominator. One significant difference is that since there is a variable in the denominator, we need to avoid any solution that leads to dividing by 0, since dividing by 0 does not exist. If you're not sure what I'm talking about with dividing by 0, let's take a quick example. If I said, what's 8 divided by 4? You would say the answer is 2. And why is 8 divided by 4 2? Because if you take 4 and multiply by 2, you get 8. Okay, well, what if I said, what's 8 divided by 0? Okay, well, that would equate to saying 0 times what equals 8. Well, anything times 0 is 0, so there is no answer to 0 times something equals 8. So along those same lines, there is no answer to 8 divided by 0. So all of these rational equations we're going to do, we need to make sure that our solution for x does not involve us dividing by 0. Okay, so let's go to example 3a, which is 1 over x equals 1 over 5 plus 3 over 2x. So difference from just linear equations with fractions is you want to start by making a note of what x cannot equal. So we want to say x cannot equal, if we look at what we have, if x is 0, we'll have 1 divided by 0. And this one, if x is 0, 2 times 0 is 0, and we'd still have 3 divided by 0. So we want to make a note that x cannot equal 0. If we get 0 at the end of the problem, we're going to conclude that there is no solution to the equation. Okay, and then we want to proceed just like we did with our linear equations with fractions. Identify the least common denominator. Start with the numbers. We just have two numbers in the denominators, 5 and 2. 5 and 2 both divide into 10. So part of our least common denominator is 10. And now look at our variables. We have x and another x, so we want to include x in our least common denominator. So just like with linear equations with fractions, go through, multiply both sides of the equation by 10x, which again will equate to multiplying all of our terms by 10x, and then simplify. Okay, there's no number in the denominator, so the 10 stays, but x over x, we can cross out those x's, leaving a 10 and the 1 inside. Our next fraction, 10 in the numerator, 5 in the denominator. 10 divided by 5 is 2. So we can cross those out, leave a 2. And there's no x in the denominator this time, so the x stays, and we have 2x times 1. And our last fraction, 10 divided by 2 is 5. And an x in the numerator and an x in the denominator, we can cross those out. So that leaves us with a 5 and the 3 inside. So multiplying, we have 10 equals 2x plus 15. There's only one x, 2x. Okay, so let's leave that there since it's already on one side and there's no other x's to move. Let's eliminate this constant by subtracting 15. 10 minus 15 is negative 5 equals 2x. Last step, divide by 2. Negative 5 divided by 2 is negative 2.5. Typically, you want to leave your answer in fraction form. So see if that simplifies. This is a fairly easy one. 2 does not divide into 5, and that's the only factors of 2. So this does not simplify. So your solution is negative 5 halves. Again, if you were to get x equals 0, because of that, you would have to conclude that there's no solution. Okay, let's look at example 3b, another rational equation. Okay, and in 3b, we have 5 over 2x equals 17 over 18 minus 1 over 3x. Okay, so start by saying what x cannot equal. If x is 0, 2 times 0 is 0 in the denominator. And if x is 0, 3 times 0 is 0 in the denominator. So on this one, x cannot equal 0. Now let's identify the least common denominator. Looking at our numbers, 2, 18, and 3. Again, start with the largest, 18, and see if the other two numbers divide into it. Well, 18 divided by 2 is 9, and 18 divided by 3 is 6. So 18 is part of our common denominator. And we also have an x here and an x here, so we want to include an x with our least common denominator. So multiply both sides of the equation by 18x, which will equate to multiplying all three terms by 18x. Okay, and then go through and simplify. 18 divided by 2 is 9. And an x in the numerator with an x in the denominator cancels, leaving the 9 and the 5 inside. Okay, next one, 18 over 18, those 18s cancel. And there's no x in the denominator this time, so I keep that x with the 17 inside. And our last fraction, minus 18 divided by 3 is 6, so we want to cross those out. And an x in the numerator and an x in the denominator, we can go ahead and cross those out, leaving us with a 6 and the 1 inside. So multiplying, we have 45 equals 17x minus 6. Okay, we only have the 17x, so let's eliminate the minus 6 by adding 6. 51 equals 17x, and then divide by 17. 51 divided by 17 is 3. So x equals 3 is our solution. Okay, we're going to end our section with just looking at some brief application problems of linear equations. So application problems are just equations that have been used to represent or model a real-life situation. So example 4 says that c equals 1,388x plus 24,963 represents the cost C X years after 1980 of something that cost $10,000 in 1967. In what year will cost be $77,707 for something that cost $10,000 in 1967? So a couple things to point out. C is cost, and X, it says, is the years after 1967. So if X is 10, that's 10 years after 1967, which would be 1977. So in this problem, it says in what year, so we're asked to solve for X, and we're given a cost. Cost we're given is $77,707, and it says to solve for the year, which will involve us solving for X. Okay, so we want to solve this equation for x. So just like our other ones, except with just slightly larger numbers. So we'd want to start by taking and subtracting negative 24,963 on both sides. And when we do that, we can cancel on the right, since that equals 0. And then subtract on the left-hand side, and we'll be left with 52,744 equals 1,388x. Our last step, divide by 1,388. And we get then that x is equal to 38. Okay, remember that means 38 years after 1967. So our final answer of what year is this happening, we take the year 1967, and we add 38 years to that. And what we get is that that would be in the year 2005. So there's our answer, the year 2005. Okay, so that's the end of our examples and our notes. So proceed to opening up the rest of your problems in section 1.2. And please feel free to let me know if you need any help with any of the questions. Use the Ask My Instructor link and let me know what you need help with.